Okay, 5th of February, this is another reminder. Okay, we are going to, 5th of February is Monday. Okay, we are going to do a replacement class. Okay, according to the Uniraza, you have to use the same link. Okay, the same link, the same meeting passcode, and the same is the same platform, which is Zoom. Okay, on 5th of 5th of February, Monday. Okay, so the class I set it to be like 8:30 until 11 p.m. Okay, so I will try to do our class. Okay, I will try to like do our class for like 1 hour. Okay, for 1 hour, another 1 hour and a half. So this one is, yeah, another 1 hour and a half, we do midterm. Okay, so 1 hour class, 1 hour class, another 1.5 hour will be your midterm. Okay, your midterm, you need to switch on your camera. Okay, you need to switch on your camera. I will invigilate you. So please be on time. Okay, please be on time. All of your midterm also will be done via Eurox. But let's say, okay, if my Eurox is still not working, okay, I hope that I can solve it by this week. Okay, not by this week, by next week. Okay, if my Eurox is not working, okay, I will let you know. Okay, I will let you know by, I will email all of you using the, okay, using my other email. Okay, so your midterm will be 1.5 hours. Okay, I decide to do like 2 parts. Okay, I have already mentioned to you. Part A will be like similar, like short essay question. Maybe it's like true, false, and also matching and fill in the blanks. Okay, fill in the blank. And part B will be, this one will be case study or essay question. Okay, I received some feedback telling that for the short term, okay, short question, okay, the time is very limited. Yeah, okay, the time is very limited. That's why you have to manage your time wisely. Okay, same for midterm. Okay, so for part A, I will use 30 minutes. This one is 30 minutes. And for part B, it will be 1 hour. Okay, so you need to, okay, so this one, yeah, but you can submit once you can submit for the full 1.5 hours. Okay, so part A is 30 minutes and part B is 1 hour. Okay, so you have to manage your time wisely to complete all these 2 sections. Okay, so that in order for you to contribute 100% for your midterm. Okay, so that's all. Okay, for the tips, okay, yeah, you have to study chapter 1 until 4. Okay, you have to study for chapter 1 until 4 because this is invigilation by open book. So I don't know what tips that I want to give it to you, but okay, you have to study all of the, okay, what you look at the learning outcomes. Okay, usually, okay, for every chapter, I will ask you, okay, according to the learning outcome that you should master on. Okay, so your midterm will be, the tips is, okay, look at the learning outcome from chapter 1 until chapter 4. Okay, look at the learning outcome from chapter 1 until chapter 4. Okay, and you have to, okay, master all the learning outcomes. So I will question you based on that. Okay, I will question you based on that. Okay, so this is like open book because it's online, right? So you can just refer anywhere. So make sure that you understand all of the learning outcome. Okay, you understand all of the learning outcome. You know what it's all about. Okay, then you might be able to answer my midterm. Okay, so today for your final assessment, okay, I'm still like drafting your paper. Okay, I'm still drafting your paper. Okay, on Monday, I will inform you, okay, how this final assessment will be. Okay, your final assessment, okay, this is like a introduction induction. Okay, your final assessment, I will release on 14. Let me show, because it has a specific time to do it. Okay, so your final assessment, okay, I thought that we have to release on 12. No, no, it's actually from 14th of February until 20th of February. Okay, so 14th of February until 20th of February. Okay, so this one only contribute 30%, and you have 7 days to do it. Okay, you have 7 days to do it. Yeah, okay, you have 7 days to do it. So your final assessment also has 2 parts for you to do it. Okay, but I'm not sure. I'm still drafting, and maybe this time not video. Okay, maybe this time is not video. Okay, so let's see how. Okay, so there will be one part. Okay, we will have a part A and part B. Part B, I know I will do some essay and case study. Okay, part A is I want to make a small project, actually a mini project using data mining. Okay, but since you are not been exposed to any types of software, any types of programming, so maybe I will come up with an analysis output, then I need you to interpret it. But let me see what I'm still like brainstorm what I should do on part A. Okay, it's still under construction. Okay, so that's all about. Okay, yeah, I received Roshani, but you did not attach your paper, only the answer. Please email me again together with your answer and the paper. Okay. Thank you. Okay, so yeah. Okay, my Europe also not working like for a week already. So I have to sort it out because we have midterm. Okay, but don't worry, your submission is safe. Okay, your submission is safe in the Europe, but maybe you just need. Okay, so today I'm going to cover this chapter 5, and a bit of chapter 6. Actually, I want to cover chapter 5 and 6. Okay, today. But I haven't prepared for the whole chapter 6 yet. So yeah, only part of it. So I will like teach you only half of the chapter 6. Okay, so learning outcome for this chapter 5 is, okay, you have to define what is the attribute-oriented analysis. Okay, what is attribute-oriented induction? Okay, what is the process involved in attribute-oriented induction, and what is the attribute relevance analysis? Okay, actually it's the same thing. Okay, actually it's the same thing. Okay, so we use data minings in various fields, okay, and like business, health, education, and engineering. Okay, so when conducting data mining on a database, okay, that contain large volumes of data, so we have various techniques, okay, to use in order to get the patterns that are hidden in the data. Okay, one of the technique is attribute-oriented analysis. Okay, so the data miners used to identify and extract data patterns from large volume of data in a database. Okay, attribute-oriented analysis use attribute-oriented induction to analyze the data attribute. Okay, so one of the technique to minimize, okay, the dimension of the data, okay, the volume of the data, the size of the data, we use attribute and oriented analysis. Okay, so in your chapter 5, okay, I will introduce you what is attribute oriented induction. Okay, what is attribute? Actually, it just wants to find a pattern behind the data. Okay, attribute-oriented analysis, okay, is defined as the use of attributes of entities to conduct analysis on the data during the process of data mining. Okay, it can be defined as a field of data that forms a representation of the features and characteristics of the data object. Okay, so in data mining, you will deal like in a big data, maybe million, maybe like 100,000. Okay, maybe like is a very big data. So you need to be more, okay, you need to choose, okay, what attribute that is belong to your study objective. okay, and what is not. So you have to find which data is related to your research and which data is not related to your research. Okay, so that's why we use attribute-oriented analysis. Okay, so the data mining analysis is difficult and expensive because of the large and extensive volumes of data. Okay, so data attribute, okay, usually selected and generalization is conducted on them. Okay, what is it? Okay, so it checks over patterns and relationship between data object using the attribute. Okay, I think I have teach you how to use the what is the attribute. Attribute is the your name of the variable. Okay, let's say, okay, you have the economic statistic data. You have household income. You have number of household. You have what is it? You have like education. You have like cost, you have like a type of house, okay, type of household, something like that. Okay, so you need to find which attribute that relates to your study. Okay, a collection of this attribute is what shows that the description of a data object, and they are referred as an attribute vector or feature vector. The attribute-oriented induction is approach used to conduct data generation and selection in the attribute-oriented analysis. Okay, we use attribute-oriented induction. Okay, so this is a like machine learning, okay, machine learning method. Okay, so that you will teach, okay, your using the algorithm, okay, how your AOI, okay, will define the pattern in your data. Then they will ultimately, okay, select it for you. Okay, so we have few types of data attributes. Okay, we have few types of data attribute. Okay, this is a statistic. I think I have taught you in data mining, if I'm not mistaken. Or like, okay, so the attributes. Okay, so we have two broad categories. Which one? Okay, which is qualitative and quantitative. Okay, we have qualitative and quantitative. Okay, in qualitative, okay, there are three types of qualitative. Okay, there are three types. The first one is nominal. Okay, what is nominal? Okay, nominal is something that okay, usually name, okay, something that you cannot order it. Okay, you cannot order it because like color, attribute color. Okay, like blue, white, red. Okay, another example is, let's say, okay, like religion. No, race, I think race, which is, okay, Malay, Chinese, Indian, Chinese, okay, Chinese, Indian, okay, maybe like Lebanese, okay, this one like others, okay, others like other ethnicity and other ethnicities, this one is like, okay, in Malaysia, something like that. Okay, another one is maybe the eye color, okay, blue, brown, yellow, like blue, brown, green, okay, something like that. Okay, so that is called like nominal. Okay, another one is maybe, okay, types of blood. Okay, so A, B, and also O. So this is also a nominal attribute. Okay, something that usually you cannot categorize it. Okay, if you cannot categorize it. Okay, so another one for binary attributes is, sorry, qualitative attribute is binary attributes. Okay, binary attribute, the name itself suggests that it only has two outcomes. Okay, it only has two values. Okay, like example, COVID test. Okay, like COVID test will be positive or negative. So it means that only two attributes involved. Okay, so another one is like female or male. Okay, two values like, okay, sex, which is we have female or male. Okay, like COVID-19 is a positive or negative, or maybe another one is, okay, yes or no, like true or false, something like this. Okay, so we have two types of binary attribute. Okay, whether it is symmetric or whether it is asymmetric. Okay, symmetric means both value can be recorded equally important. Okay, so symmetric binary means it has two outcomes and it is equally important. Okay, so like in the example, the employment opportunity, the attribute gender can have either values that are male and female, which are both important. Okay, so like male and female, both important, right? Okay, so two outcome, it is both important. It's like 50-50. Sorry. Okay, and we also have asymmetric binary, where both values are not equally important. Okay, both values are not equally important. So let's say you want to conduct a COVID-19 test. Okay, it is important to identify a positive case since it may lead to death, okay, rather than ignoring it. So we know that, okay, so we have a two outcome. Okay, so it is positive. Okay, so it leads to death or we can just ignore it. So it means that, okay, it is not equally important, but we know that it is a positive COVID case. Okay, it is a positive COVID case. Okay, it lead to death or we just ignore it. Okay, another qualitative attribute is ordinal. Okay, is ordinal. Okay, ordinal attributes whose values show a definite sequence or order. Okay, so for ordinal, okay, we can order it. Okay, but the weight and importance between the values may not be defined. Okay, there's no weight. Okay, but we can order it. Okay, let's say, okay, in the example below, okay, the sequential flow of the value depicts importance, but the importance is not known. Okay, so which means that we can like order it, but the importance is unknown. Okay, let's say marks of a student. Okay, so we can grade with values A, B, C, D, and E. Okay, the order may signify importance since it is in ascending order, but the magnitude may not be defined. Okay, so we don't know the importance of it, but the grade can be sorry, okay, according to the A, B, C, D, and E. Okay, and another one is maybe you want to do like level of satisfaction. Okay, level of satisfaction. Okay, we can order it like not satisfied. Okay, neutral, and maybe satisfied. Okay, low. So maybe you can like do it more. Okay, more detail. It's like very not satisfied. Okay, not satisfied. Okay, neutral, satisfied, very satisfied. Okay, so which means that we can order it, but there's no weight and the importance, okay, between the values not defined. Okay, so that's all about the quantitative attributes. Okay, and we can have a quantitative attributes. Okay, so for quantitative attributes, okay, the name itself, before it's qualitative, so which means that it is something that is not is non-numeric. So for quantitative is numeric. Okay, so there are three types of quantitative attributes. Okay, so we have numeric attributes, discrete attributes, and last one is continuous attribute. Okay, so numeric attributes, okay, it shows the measurement to quantity with their values being represented in real values or integers. Okay, so what is a real values integers? It can be Okay, positive or negative. Okay, it can be positive or negative. Okay, so the measurement, okay, they will be represented in real values or integers. So which means that it must be a real number or integers. Okay, so there are two types of numeric attributes. Okay, it can be as interval or it can be ratio. Okay, what is the difference between intervals and ratio? Okay, so what is interval? Okay, interval scale attributes contain an interpretable difference in value. Okay, but they do not have a reference point that is correct or does not have a correct 0 point. Okay. Okay, so what is it? Okay, what is it? Okay, so for the interval, okay, you can categorize rank and okay, find between the neighboring data points, but there is no true zero. Okay, there is no true zero. Okay, so what is it? Okay, so okay, there is no true 0 point. Okay, like temperature. Okay, like temperature. Okay, we don't have a zero, correct zero. We don't have any true 0 point because temperature can be as low as negative 50 degrees Celsius until let's say 100 degrees Celsius, right? Okay, it can be like lower than that. Okay, like another one is like for IQ test, like test score. Okay, like personality test. Okay, personality test shouldn't have any 0 point. You can have like negative 10 marks score, okay, because your personality like that, until like maybe like more than 110. So you don't have any correct 0 point. Okay. So a 0, okay, this one in this category, in the interval is arbitrary. So it does not mean that, okay, it does not mean that it is not important. Okay, but it doesn't have any correct 0 point. Okay, it can be lower than 0. Okay, but I show you what the operation that can be done for the interval and also ratio after this. Okay, for ratio, okay, these are numerical attributes that contain a fixed 0. Okay, so it has a fixed 0 or reference point. A ratio scale measurement is usually a ratio or multiple of another value. Okay, so we can conduct calculation of the difference between the value of ratio scale attribute. We can find mean, mode, median, quantile range, and all. Okay, so the values of this attribute are usually ordered. Okay, for ratio, because we have like zero point or like a reference point, so we can conduct calculation to find mean, median, and mode. Okay, or quantile range. Okay, but for interval, because we don't have any specific reference point, okay, any specific response point, so we cannot find like mean, median, and mode, or like the range and all. Okay, so for like, what is the example for ratio? Okay, like height, weight. We know that height, weight all has the fixed 0 point, right? Okay, like age. Okay, so all these have 0 points. Okay, so a true 0 means there is an absence of the variable of interest. Okay, okay. Next category of attribute, quantitative attribute, is discrete attributes. Okay, what is discrete attribute? Okay, discrete attribute are attributes that contain values that are finite. Okay, so finite means it must be in round numbers. What must be in round numbers? Okay, something that you can count. Okay, what you can count? Okay, so they said that number of teacher, doctors. Okay, so something that you can count. Okay, that is discrete attributes. Okay, there is discrete attributes. Okay, so discrete attributes like number of okay, like zip codes. Okay, so it must be in round number. That is like discrete attributes. Okay, another quantitative attribute is continuous attributes. Okay, continuous attributes. Okay, these are attributes that contain an infinite number of values. Okay, usually continuous data attributes are the float type. Okay, the continuous attributes is of real number. So the attribute height might have values. Okay, continuous attribute is similar like ratio. Okay, in statistics, we don't have three categories. We only have two, which is like discrete and also continuous. Continuous has interval and ratio. Okay, but for data mining, okay, it goes a bit different. Okay, so let's say that this one is attribute height. We have 47.3, 67.8, and all that. Okay, so for continuous attribute, it can be in decimal. Okay, it can be in decimal. Usually, this one is for the measurement. Okay, like monetary. Okay, like measure any measuring unit. Okay, because it is in a float type. Okay, so now here, okay, we have learned what is the attributes. Okay. Okay. I said to you, okay, about the interval and ratio. What is the operation that can be done, okay, in the for the interval and ratio attribute? Okay. So I give you an example. Okay, so let me show my screen. It's easier. You can share screen. Okay, let me cancel this first. Okay, so this is a mathematical operation that you can do in data mining, okay, for the attribute. Okay, so if it is nominal, okay, you can only use equality and non-equality, but you can find the mode. Okay, what is the highest number of this category? What is the highest number of blood A group, something like that. Okay, but you cannot find the standard deviation or variance, okay, and all that. Okay, for ordinal, you can find the quality and inequality, okay, and also you can define the comparison, less than, equal than, sorry, greater than, less than, okay, but, and you can find mode and median from the ordinal, and range and interquartile range. Okay, range is the difference between largest value and the largest value and the smallest value. Okay, there is range. Interquartile range means you have to find the first quartile, second quartile, third quartile, then third quartile minus with the first quartile. Okay, and for interval attributes, okay, you can do more by finding equality and equality comparison, and you can also do addition and subtraction. Okay, using the interval, you can find mode, median, and also the arithmetic mean. Arithmetic mean means like the mean. Okay, for the measures of variability, you can find range, interquartile range, standard deviation, and also variance. Okay, because there's no true 0 point in interval. Okay, that's why, okay, for ratio, okay, we can find equality, comparison, addition, and also we can do the multiplication and division. And we can also find mode, median, arithmetic mode, and also geometric mean. Okay, and we can find range, interquartile range, standard deviation, variance, and relative standard deviation. Okay, so what is the arithmetic mean and geometric mean? Arithmetic mean is usually like the common types of mean. Geometric mean is a method used for averaging values from scales with widely varying range for individual subject. Okay, you don't have to know like all this, it's just like extra. Okay, it is something extra that I want you to like understand it and to know about it. Okay, so Okay. Okay, so that's about the types of attribute. Okay, that's about the types of attribute. Okay, any question? Okay, so now we go to attribute-oriented induction. Okay, so we know all the types of attribute. We must teach our machine, our software, okay, to understand, okay, how to categorize it, okay, how to select it, how to discard it. Okay, we have to teach the machine, okay, how to do this, okay, how to do it. Okay, so attribute-oriented induction, okay, is an approach in the attribute-oriented analysis that is based on characterization in data generalization and summarization. Okay, so it was proposed some years before the data cube approach was introduced. You remember the data cube? Okay, based on the dimension. Okay, why the data cube approach is used to perform the offline aggregation before the online analysis processor before submitting a data mining query for processing attribute-oriented induction approach is an online analysis technique that is based on generalization of data attributes and conducted by submitting a query to access a relational database. Okay, for attribute-oriented induction, okay, we use for the relational database. Okay, we use for the relational database. Okay, okay, so usually, okay, attribute-oriented induction, okay, is a data mining algorithm. Okay, it's used for extracting knowledge of relational data. Okay, and it is a clustering, we also call it as clustering algorithm that works by transforming the value of the attribute and convert into others, okay, that is more relatable to our to our study. Okay, so it's kind of grouping, yeah, something like grouping. So we have like few process involved in attribute-oriented induction. Okay, the first one is collection of the task relevant data. Okay, it's often referred to as initial relation. Okay, it's carried out by running a relational database query to identify and gather the relevant data that will be required in the mining process. Okay, first you have to like collect the relevant data. Okay, collect all the relevant data. Okay, so at this time, okay, you have to like select your data. And second stage is we have to perform the generalization. Okay, so this is the process, okay, of summarizing the data by bringing the common denominator in the data set. Okay, usually we carry out it by conducting attribute generalization or attribute removal. Okay, for this time around, okay, so we have to select which one is like which it based on the like the researcher, okay, which attribute that is important to your study. Okay, like this one is both based on judgmental. Okay, and to which one to remove. Okay, third step is the aggregation. Okay, so we already have the generalized data set, the one that we remove. Okay, this is the process of classifying the data is generalized to cluster. Okay, this time around, we generalize the tuple, merging the identical data set and accumulation of the respective counts. Okay, after we remove some of the attribute that is unwanted, okay, so we have to generalize the tuple. Okay, if there's any identical data set, we have to merge it and accumulate the respective count. We have to do the like frequency, something like frequency table, okay, to see it. Okay, and we have to do the size reduction. Okay, the data, the one that we have removed and generalized and aggregated it, okay, it will be reduced in size. Okay, it will be reduced in size. Okay, we will look at what is the aggregation technique on next part. Okay, so how to select and what to like, how to do a threshold, okay, between all this. Okay, how to do a threshold for the attribute. Okay, it's similar like sorting and filtering, yeah, in Excel. Okay, but this data mining, it involves like big data. Okay, so there's a few principles of attribute-oriented induction. Okay, the first part is data focusing. Okay, this principle is conducted in the initial relation step. Okay, it involves conducting analysis on the data that is relevant to the task. Okay, it includes analyzing the dimension. Okay, so okay, we have few principles in attribute data. We must know what and be clear what is your study all about, what is your objective. So we must know that what the types of data that we have to focus on and remove it. Okay, so let's say you want to do a study about COVID. You want to study about COVID. Okay, you have many types of data, like uh, the like health status, okay, any disease earlier, like previous disease, or maybe you have like symptoms, okay, or maybe you have like household income, okay, maybe like type of car. Okay, so we know that, okay, some of the variable attribute here, okay, is not important, okay, in our COVID experiment. So like this, income, types of car, okay, maybe it's not important, maybe even gender also, not important, something like that. Okay, so you must be clear. Okay, you must be clear what is your, what do you want to find out before you put into data mining process. Okay, and okay, and another principle is attribute removal. Okay, attribute removal is the procedure involved the identification and deletion of the redundant attribute values. Okay, when it's conducted on a large data set, no generalization operator that can be used to generalize the attribute value with other attribute value, or where other attribute can be used to express the high level concept of the attribute being removed. Okay, so like I said, okay, we must focus on what our research is, and if there's any like redundant attribute values, so what is redundant attribute value? Maybe like in COVID test here, you have like health status, okay, and you also have another one which is like fitness. Okay, we know that these two are like redundant, it's the same thing. So we can just use one of the attribute instead of keeping two, because we want to reduce the size. Okay, so another one is like if the types of attribute is not important, you can also remove it. Okay, next is attribute generalization. Okay, this principle is based on conduction on a summary on low-level attribute to high-level concepts of the attribute. Okay, so okay, first we must focus and remove it. Another one is you must okay to reduce the dimension and also to reduce the size of the data. Okay, we must generalize it. Okay, so to generalize it, okay, let's say we have like attribute marks 70, 65, 50, 40, 45, and 55. Okay, so we must generalize it into a category like 70 and 60 pass, 50 and 50 satisfactory, and 55 to 50 being failed. Okay, we categorize it. Okay, usually, okay, when we categorize like this, okay, so we do like a level. Okay, we do level like pass. So we put it like 70 to 65. Okay, satisfactory, 55 to 50, fail. Okay, 40 to 45. Okay, something like this. Okay, so which means that we can reduce it. Okay, but the problem in this is if you put the generalization is too wide, okay, your data prediction or data forecast or data analysis, okay, somehow will not be somehow it create a misleading output. So the thing is you have to be, okay, by experience, okay, you will know how to generalize it. Another one, the principle is attribute threshold control. Okay, attribute threshold control is states that if the number of the different values of attribute, okay, in an intermediate relation is bigger than the required and necessary magnitude of the attribute to be exceeded, generalization should be conducted on this attribute. Okay, so which means that, okay, it's something like filtering. Okay, something like filtering. Okay, like the distinct values of the attribute should be less than or equal to the threshold of attribute. Okay, and the attribute threshold is usually between 2 and 8. Okay, so we need to do the threshold control. So which means that, okay, we have to do, okay, the threshold must be between 2 and 8. So, okay, I think this one, the explanation is a bit misleading. Okay, threshold control means that, okay, so you have to put like a threshold. So which means that you only select, okay, the data, let's say from level of satisfactory is 70 to 50. Right, this one is 70 to 50 only. Oh, sorry, 40 marks only. So, okay, anywhere else that like falls, okay, below or above this range, okay, it will be discarded. It will be discarded. Okay, another one is maybe you want to do like obesity research. Okay, you want to find the obesity research and you want to find out, okay, what types of food that affecting them. Okay, so your obesity, so your focus in obesity. So the one, okay, that is not like the weight below than the BMI. So the BMI must be in obesity level. Okay, so the low BMI, okay, or the like the natural the normal BMI will be discarded. So we put a threshold control for this. Okay, we put a threshold control for this. Okay, there is like another principle. Okay, next one is the generalized relation threshold control. Okay, this principle is concerned with controlling the final size or relation. Okay, it states that if the quantity of the tuples in a relation that has been generalized remains to be larger than the thresholds of the generalized relation, it is wise to conduct further generalization so as to reduce the size of the relation. Okay, this is like the example, the combination of like threshold and also the generalization. Okay, so if it is not belong, okay, to the threshold and the generalized relation, okay, we like remove it. Okay, so if it is not belong to the threshold and the generalized relation, we discard it. Okay, why? Because we want to reduce the size of our data. Okay, because we want to reduce the size of our data. Okay, this is like similar like sorting and filtering function in Excel. Okay, yeah, sure, Chi Chong. Okay, yeah, sure. Okay, that's like, okay. What is the attribute generalization? Okay, attribute generalization, okay, is the process of summarizing attribute values from low-level concept to high-level concept. Okay, there is a large data set of distinct values in attributes. Okay, a generalization operator. Okay, so before that, okay, so I have shared with you, okay, what is the operator, okay, that can be done for nominal, ordinal, interval, and ratio, right? Okay, so this operation can be done in generalize the attribute, okay, and to define and also the for the use for the generalized and also the threshold control. Okay, it is based on the follow. So for the attribute generalization, okay, we can do like less than, equal than, not equal, okay, greater than, and all that. Okay, it's based on the following rule. In an instance where there is a large set of distinct values in an attribute, generalization operator should be chosen and the application of the operator conducted on the attribute. Okay, so when there is a large set of distinct values, okay, so a generalization operator, okay, we should choose, okay, which is whether you want to choose like greater than or less than or equal or non-equal. Okay, so you have to specify it. Okay, attribute generalization can be conducted with nominal attribute and structured attribute. In nominal attributes, okay, the process defines a subgroup by conducting a selection on two or more multiple dimensions of the data attribute. Okay, so if you still remember, okay, the data cube. Okay, the data cube, if it is nominal attribute, what is nominal attribute? Like blood types, okay, like blood type, hair color, eye color. Okay, so we do the attribute generalization by selecting, okay, two or more multiple dimension of the data attribute. Okay, so we just select which types of attribute, which types of attribute that we're going to choose. Okay, so for structure attributes, okay, the process is conducted by moving up the concept of hierarchy. Okay, so for the nominal, we just select what types of data, multi-dimension of the data attribute. For the structure attributes, okay, we conducting by moving up the concept hierarchy. It's like a decision tree. Okay, this one I think I will explain more in chapter 6. Okay, I will explain more in chapter 6. Okay, any question? Any question?
Oh, no question.
Okay, so we have few types of attribute selection. Okay, we know the principle is straightforward. Okay, generalize it. Okay, we can generalize using the structure, structure, what is the name? Structure generalize. So we can use it like by using the nominal attributes or the structure data attribute. Okay, this one is like same like decision tree, but I will explain it in more in chapter 6. Okay, attribute selection. How to find, okay, how to select which one. It's just not simply remove, okay, discard and keep it and put like, okay, we have like a few methods to do it. Okay, we have few we have a few methods to do it. First is, okay, attribute selection is the technique used in data mining to conduct the reduction of data to a size that is manageable. We know we deal with a large number of data, okay? So, okay, we want to reduce, okay, the data Okay, so we have to find the smallest attribute, okay, the smallest number of attribute, okay, to remove the irrelevant attribute that is not affect our research. Okay, when we do data mining on a reduced size data, okay, it can save cost, okay, and also it can save time. Okay, so we have few methods of selecting attribute. Okay, the first one is stepwise forward selection. Okay, what is stepwise forward selection? Okay, first, empty attribute set as the smallest set. Okay, first, we don't put any attribute. It's like 0 data. Okay, then, okay, the attribute that are found to be very relevant are picked and added to the smallest set. Okay, and we found that, okay, this attribute is relevant, then we put it one by one. Okay, so we put like, let's say for COVID, research. Okay, so we have like, so we put one by, we know that age is important, so we put it. Okay, this is stepwise. Next is, we know that the, okay, health status is important, we put it. Let's do this. Okay, then we put one by one, 3, 4, until we put all the relevant factors. This is called stepwise forward selection. Okay, another method is stepwise backward elimination. So for this, okay, for this, it means that all attributes are put into the equation as the initial attribute set. Okay, so when we do iteration, one attribute that has the least relevance is removed from the set. Okay, stepward backward elimination means, okay, like forward, we put one by one. Relevant, we put the relevant, we put one by one. But for stepwise backward elimination means we put everything, okay, lump sum, maybe like 10 attributes. Then, okay, we do the iteration, okay, using the data mining. Okay, so the one that is irrelevant, we remove it. Remove one by one, remove until the one that is left in the data, the one that is left in the data set is the one that is relevant to our study. Okay, we remove one by one. So that one is stepwise backward. Okay, we put everything, then we remove it. Okay, like for forward, is one by one. Okay, next is combined forward selection and backward elimination. Okay, so this method combines both forward selection and backward elimination to identify the most relevant attributes effectively. Okay, it is usually the best and most commonly used method of attribute selection. Okay, so this one, okay, it means that we have to find the, okay, we try both. Okay, stepwise and backward elimination. We try both. Okay, first we try stepwise, and then we try backward. Okay, then we compare it, then we put the attributes outcome for this and this. Okay, then we combine it together. Okay, usually it's end up, okay, if the same data set that is used, usually it will end up the same attribute that is kept in our relevant study. But somehow, okay, when you run for stepwise, you get different attribute, but when you run for backward, you will get different attribute. Okay, that one is like a big conflict between these two outcomes. Okay, so it based on the method that you choose. Another one, methods of attribute is decision tree. Okay, oh, I thought in chapter 6. Okay, but this one is decision tree. This is like in structure attribute. Okay, this technique takes into account, okay, the use of decision tree of the selection of attribute. Okay, a flowchart-like structure is constructed with nodes showing a test on the attribute. So the branch of the node depicts the outcome of the test, while the leaf node is the prediction of the class. Attributes that do not form a part of the tree are removed since they are considered to be irrelevant. Okay, for the decision tree, I show you how is it. I already find it, but it's gone. Okay. Now we're going to do the attribute relevance analysis. Okay. Okay, so when we conducting class categorization of data, okay, it's not easy to identify the attribute to be included in the analysis. Okay, to identify the irrelevant attribute, okay, should be excluded during the process of attribute-oriented analysis. Okay, so when this process is including the characterization process, it's often referred to as analytical characterization. Okay, analytical relevance analysis is also conducted, okay, in conjunction with comparison, and the process is called analytical comparison. Okay, so after we do the attribute generalization, the aggregation, so we want to do the relevance analysis. Okay, so class characterization, okay, has two major limitations. Okay, first, if you have like complex object by derivative like OLAP, handling complex objects. Okay, and second is, okay, lack of an automated process of conducting generalization. Okay, so when we do the class characterization, we have two limitations. When we handle complex object, okay, especially we have like okay, like video or like okay, any data that is involved like video, like photo. Okay. Okay, so another one is like lack of an automatic process of conducting generalization. So when we do manually, okay, directed by the user on the dimension that should be added during the class characterization process. Okay, so if there's no automate and if it's like complex object, okay, so that is the limitation for like class characterization. Okay, so to determine the relevance of attribute, okay, is important so that the system is not fed with too many attributes, thus making it slow to process, or feeding it fewer attributes, making the data mining process to be incomplete. Okay, actually, this is, okay, how after you like remove the attribute that is not important, after you like filter out, after you put the threshold, okay, you want to find whether it is relevant or not. Okay, the highness in the relevance of an attribute or dimension concerning a particular given class is determined if the likeliness that the values of the given attribute or dimension may be used in distinguishing the class from other classes. Okay, so like you want to distinguish expensive and cheap motorbike, the color of the motorbike may be irrelevant when distinguishing between the two, but the model of the motorbike and engine may be relevant attribute that could be used to distinguish between the two. Okay, actually this is like repeating like for the attribute oriented induction. Okay, same. Okay, so okay, after we remove the attribute, okay, so we also want to find the dimension relevant. Okay, which one is important, and okay, dimension relevance is also important, and the process should be conducted at different levels of abstraction. Okay, the most relevant level of dimension, that is what should be added in the analysis. Okay. Sure. Okay, it's like you want to determine the salary of employees. Okay, some dimensions such as birth date, and birth month may be irrelevant, but the birth year, birth decade, or age relevant may be relevant. So when conducting class comparison in data mining, the target class and the classes to be distinguished from are clearly outlined in the mining query. Okay, this is different for conducting class characterization and data mining, as only one class is characterized and no distinguished classes. The class is outlined. Okay, so actually this is like same like attribute induction is same. Okay, it's same. So you have to select what your dimension you want, what the attribute you want. Okay, which one is relevant, which one is not relevant. You can use backward elimination, you can use stepwise forward technique, you can use decision tree, and you also can use decision tree, and also you can use the combine between stepwise and backward. Okay, so this is another like perspective, okay, how to do the attribute selection. Okay, some methods are introduced to conduct dimension or attribute relevance to weed out statistically weak and irrelevant attributes. Okay, this will help to retain and rank the best relevant attributes to be used in data mining process. Okay, some like what I explained before. Okay, so after we know what is the dimension, what is the attribute that we want. Okay. Okay, so we test it. Okay, which one is significant and which one is not significant. So the one that is not significant, we remove it. Okay, so it will help us to retain and rank the best to be attribute to use to carry on with the data mining. Okay, the main aim of attribute relevance analysis is to bring forth a computation of the measures that are used to show the relevance of an attribute or dimension concerning a class. Okay, so sometimes we use gene index and information gain. Okay, usually after we use the backward, okay, after we select which one that attribute that is keep to our research, okay, to our data mining, okay, we can also use measures, gene index and information gain. Okay, to be honest, I haven't used gene index and information gain. Usually I use AIC, BIC, okay, it's the archive key information criterion. BIC is Bayesian information criterion. Okay, so I want to see the higher the value, okay, it means that more information, okay, captured in my analysis. Okay, so the higher the AIC and the BIC value, which means that my model, my analysis is correctly predict. Okay, I didn't use gene index information gain. Okay, okay, maybe the data scientist, okay, might more like use it. Okay, usually I only use AIC, BIC, okay, and I use R square, I use a chi-square, and okay, this is like the fitness test that I use. Okay, one of the method used combined two technique, information gain analysis and the dimension-based analysis method. Okay, combination of the two methods is effective in the removal of the attribute that contain less information, leaving the more information to be used in the concept description analysis. Okay, so when we get all of the information here in AIC, BIC, R square, chi-square, okay, so we see how our model, whether it is fit or not. Okay, how is our model is fit or not. Okay, so then we do the dimension-based analysis method, then we combined it. Okay, then we said that, okay, this data, this attribute is selected, okay, and being aggregated, and we do the AIC, the relevance test, which is AIC, BIC, and all that. Okay, we see that this is the like the most harmonious model for this analysis. This is the most harmonious model. Then we come up with the conclusion of the research. Okay, this is all about. Okay, so using the dimension, we say that, okay, this attribute, okay, that this data that have this attribute, okay, is the most harmonious model for this. Okay, by supporting with the AIC, BIC, and R square and chi-square value. Okay, but the thing is, when your data is too big, okay, when your data is too big, somehow, okay, you need a lot of work to do the attribute removal and also the attribute threshold, all that. Okay, so we will talk more on in chapter 6. Okay, we will talk more on chapter 6. Okay, so okay, a part of the removing of outlier, removing of the unwanted attributes. Okay, so we have a lot of like process to do. Okay, process of attribute relevance analysis is first one, we collect the data. Okay, so we collect data for the class targeted and the class to be contrasted. Okay, the data is collected through query processing. In characterization, data is not collected for the contrasting class where the comparable is collected. So first we collect the data, then we do a preliminary analysis. This is kind of like pilot study. Okay, so after we select which attribute to be selected, okay, identify the attribute and set the attribute or actions in preliminary and relevancy. So we do the preliminary analysis. Okay, we don't do analysis for the whole data. We use only a portion of it. Okay, then we run for the attribute relevance analysis. Okay, we use the attribute oriented induction. Okay, we try to give our machine to our software to understand. Okay, to understand. Okay, how our attribute looks like. Okay, how our attribute is chosen. Okay, then we test for the using the relevance analysis. Okay, we do a preliminary analysis. If the model is work well, which means that all of the step is success. Okay, so the resulting relation achieved after the application of the attribute oriented induction is referred to as the candidate relation of the data mining task. Okay, so if it is success, then we can go for the next part, which is the removal of irrelevant attribute. Each and every candidate relation attribute is evaluated by the selected relevant analysis measure. The measure of relevance used in this step is defined and provided by the user. Okay, sorting of the attribute is conducted in accordance with the relevance that was computed. Okay, irrelevance and weak attribute usually removed after the thresholds and of the attribute has been set. Okay, the initial target, contrasting class working relation, and the initial target class working relation are the resultants of the process of this step. Okay, actually it's same like okay, so we do the preliminary analysis. Okay, and after we do that, if we found some of the model is not harmonious, okay, you have to do the we have to refine again your selection of attribute, do the aggregation again, okay, and test it again and again. Okay, so after we remove and we finalize our model, we find a harmonious model. Okay, so we do the concept description generation. Okay, we assess the performance of the attribute oriented approach. Okay, but this time a smaller set of attribute generation threshold is used. Okay, so during this stage, we consider if the descriptive mining task is comparison or characterization. Okay, the initial target contrasting class working relation and the initial target class working relation are included, but for characterization, only the initial target class working relation. Okay, this one. Okay, the sentence is very misleading. Okay, very misleading. Okay, it means that after you do the removal of relevant attributes, okay, so we want to, okay, come up with the harmonious model. Okay, then we can proceed with our next part, which is the data mining algorithm. Okay, which is the data mining algorithm. Okay, I think this part you can just ignore it. Okay, so after we do the removal of relevant, we proceed with the attribute relevance analysis. Okay, so we see whether the model is fit or not to carry out with other data mining analysis. Okay, I have done with chapter 5. Any question? Any question?
No, Dr. Anna.
Okay, thank you. Okay, if not, okay, we can begin with chapter 6. Okay, we do have only until the prediction. Okay, until prediction only. The rest is I will discuss it during this Monday, okay, before your midterm. Okay, before your midterm. Okay, give me 5 minutes. Okay, I want to sip some drink. Okay, before I begin with chapter 6. Thank you. Okay, hello. Okay, so now, okay, we are going to learn our last chapter, okay, of our syllabus. Okay, I'm going to explain half of it, no, like almost more than half. Okay, then the rest is I will explain it during our last class on Monday. Okay, so this is a data mining algorithm. Okay, so we know that, okay, for using the data mining, okay, we do the attribute selection by using the attribute oriented induction. Okay, that we do the attribute relevance analysis. Okay, and after that, after we prepare all of the data that is like fit to carry on with the data mining. Okay, so we do the data mining. So we have to know what is the data mining algorithm. Okay, so this is like only a part of it. So we have like association, classification, prediction, clustering, discriminant, and trend. Okay, so I explain these three first, and the other three I will explain in next class. Okay, so I have like introduce you what is association, what is classification, and the prediction before. Okay, so we are going further. Okay, but as a like MBA students, you don't have to know what is the algorithm. Okay, but you have to know what is it and how to use it and how to like monitor it and okay, how to monitor it. Okay, so actually there's so many like programming involved behind all the algorithm. Okay, so I'm one of yeah, I like programming. Okay, so this is like so it is, I know it is very hard for you to understand because you're not doing the programming, but you just know the function and the outcome of it. You know the function and how we use and the outcome of it. So it's a bit hard for those who like know about computer programming, you will understand what I'm talking about. But for those who don't have any background, I know it's a bit difficult for you to understand. Okay, because you don't do the programming, you don't know the theory behind all of the model that I will talk about after this. Okay, so it will be a bit difficult for you to imagine it. Okay, so for me, okay, I understand because you don't know what it's like some of the statistical and also some of the statistical terms that you don't understand. Okay, because you don't learn it, you just learn it like you don't go through the grassroots of the analysis. Okay, so you just only know the surface, but you have to know what is going on. Okay, so let's say if my explanation is not deep enough, okay, you can also like listen to the YouTube and also in Google, so many other research. Okay, but just ignore the part of the one that you have like somehow like the theory. Okay, you just ignore it, but you just have to know the function and what it work for and what is the outcome of the algorithm. Okay, that's all. Okay, for me, I know it because I'm doing the analysis and the programming and I know the theory behind it. Okay, for those who don't have any idea about it, if my explanation is not sufficient, okay, you can like look more in Google. Okay, but I will try my best to explain it to you. Okay, data mining algorithm, okay, are a set of group of calculation and heuristics that are used to create a model from the data mine. Okay, after you have removed the attribute and prepare all of the data, you do the preliminary analysis, you do the attribute relevance analysis. So we have to carry on with what our research is all about. Okay, if all your research want to find the association, if you want to find the classification, or you want to find the prediction, or you want to find the forecast, if you want to forecast, okay, for your data. Okay, so it'll be like it is. Okay, it will be like you have to prepare the algorithm for it. Okay, when coming up with a model, the data mining, okay, algorithm will begin by analyzing the data that was extracted. Okay, so as to look for pattern and trends that are specific to the required result. Okay, after you already do the preliminary analysis, find the attribute, you have to find any like trends or pattern that in your data. Okay, the data mining algorithm used the result that was gained to conduct further analysis over a variety of iterations in order to come up with the optimum parameters that be used in creating the model. When it's creating. Okay, the parameters found will then be applied over the whole set of data to help in the extraction of data pattern that is actionable. Okay, this is like repeating the attribute chapter. Okay, so you do the analysis over many times. Okay, then you find the optimum parameters, which is the optimum attribute. Okay, that will be used to create the most harmonious model. Okay, the data mining algorithm run in the extraction software, and their application is only based on the needs of the business organization. So when conducting analysis using the data mining algorithm, factors such as the accessibility of the data be inputted, time taken to respond the prediction given, and the quality of the prediction are of utmost importance to a business organization. Okay, so in order for you to carry on with your data mining, okay, so the factor involved is whether you can access the data that you want to input. Okay, how long, okay, your analysis, how long your model will take to do the analysis. Okay, and about the quality of the prediction. Okay, so is your prediction fit, okay, to the study objective or not? Okay, so that one is like in terms of business organization. Like for a researcher like me, okay, time taken is not that crucial for me. Okay, but the quality or the accessibility of the data and the quality of the prediction is important to me. Okay, so the first data mining algorithm is the association rule. Okay, association rule, okay, this is like a very lengthy explanation. Actually, association rule is to see, okay, whether the attribute is independent or not. Attribute is dependent or not. That's all. Okay, that is like that's it about it. Okay, so you want to know whether price of the car depends on the salary of the of a person or not. Okay, like that. If the COVID is related to health status or not, something like that. If eye color depends on the mother's eye color or not. So you want to find the attribute. Okay, as for association rule, the best part is you can use categorical. It's not has to be numerical. You can also use nominal, or you can also use ordinal types of data, types of attribute. Okay, so the association rule is a data mining technique to discover the relationship between two data items that are in a seemingly independent database. Okay, so we have to bear in mind, okay, that all of the data are independent. So we want to test in pair. Okay, we test this in pair, whether it has any relationship or not. Okay, in a higher level, you can also find whether it's not in pair, maybe it's three. So this independency is conditional on other attributes or not. Okay, something like that. Or in higher level, advanced, okay, so maybe it's four. So this independent may be influenced by conditional on this attribute and this attribute. Okay, so that's all. Okay, so that is like that is what it's all about in association rule. Okay, in this association rule, we use if-then statement. Okay, if-then statement. Okay, this is like programming things. Okay, to help discover the relationship. Okay, so usually you can, now data mining is more advanced. You don't have to use the if then statement anymore. Okay, but we use the iteration, many iteration, and we use the, we already have the built-in model. We just have to click it and choose which attribute that you want to test. Okay, unlike most of the common data mining algorithms that work majorly with numeric data values, okay, association rule is non-mathematical, making it suitable for non-numeric and also categorical data. Okay, so that's why I said it doesn't have to be quantitative. It can also use qualitative to find whether there is relationship between the two variables or not. Okay, the association rule mainly works with data that is stored in different types of database, such as transactional and relational database, with the goal of this technique is to find correlation, patterns, and association that occur frequently in the database. Okay, after you find whether it has relationship or not, you want to find how well is the relationship, what is the strength of the relationship, whether it's positive, whether it's negative relationship, okay, whether it is like very strong relationship, weak relationship, medium relationship, and all that. Okay, so there is one major algorithm that is used in conjunction with this technique. Okay, we use a priori algorithm. Okay, a priori algorithm is algorithm that is used in association rule, okay, to identify the frequency of the occurrence of the set of items in the data mining process. Okay, actually there's many other association rule that you can use, but a priori is one of the algorithm that is used. Okay, this algorithm makes identification of the individual items, okay, that are frequent and making extension of them to larger item sets have their efforts often in the database. Okay, so a priori is actually one of the Bayesian technique. Okay, before we carry on with analysis, a priori is like you have to bear in mind what is the assumption that you're going to make for the data. So is there any relationships? Okay, is there, what is the strength? Okay, what is the negative strength or positive or strong? So we use the a priori. Okay, a priori property is used when conducting extraction and analysis with the algorithm. Okay, this property makes the assumption that there must be a frequency in all subsets of a frequency itself. In case there is a frequency in the item set, all of the supersets will be infrequent. Okay, it must be frequency for all subsets. Okay. Okay, so it must be all frequency in all subsets. Okay, so which means that our data must not be redundant and our data must not be null. Okay. So, okay, so a priori, okay, it can improve the efficiency. Okay, okay, sorry. Okay, this one, next. Okay, a priori algorithm make use of the bottom-up approach that use candidate generation step where the frequent subset are usually extended one time at a go. Okay, then the candidate groups have themselves tested against the data. Okay, so this one is similar, the a priori is similar like forward, okay, like forward. We test it one by one. Okay, we test it one by one. Okay, so first, okay, they use a candidate frequent subset. Okay, then after that, okay, so when we say that when there's any independent relationship between this, okay, then it expand more and more. Okay, so when there are new successful extension found, the algorithm is terminated. Okay, so we test it one by one. Okay, so when they found there's a relationship, okay, so the algorithm is terminated. Okay, so breadth first search and hash tree searches are used in conjunction with a priori to efficiently count the sets of candidate items. Okay, and the a priori algorithm works by generating set, okay, of the candidate item that have length k forms a set of items of the length k1. of the length K, sorry. Okay, the candidate item that contains sub-patterns that are infrequent are removed. Okay, so which means that, okay, the one that is not relevant, that is not have any relationship, okay, in the data, okay, so we remove it. Okay, the algorithm, okay, scans through the transactional database to determine the candidate item that contain frequent set. Okay, so this is example of the a priori algorithm. Okay, so a priori is like one of it. Okay, you also have one pi, min-pi DNA sequence algorithm. Okay, so this is like a priori. Okay, this one is quite like very complicated with large. Okay, so this one is, you see that the code is, okay, so a priori is between the is T and also epsilon. Okay, K, we put it as, we start with 2. Okay, so the set for the frequency for K must not be null. Okay, so if C is include C A, okay, this one is like very mathematical. So A consists of the frequency in LK minus 1 and B is not, okay, a member of A. Okay, so DT, C is the member of CK and C is the subset of T. Okay, wait, let me show you the one that is more like one. Then, okay, a priori. Okay, this is like how to use a priori. Okay, usually we see 60%. Okay, this one is 60%. Okay, then we do the like the mathematical operation here. Okay, then we see whether which one is the which one is the associated or not. Okay, so this is an example of a priori. Okay, so a priori is actually we want to find the association rule. Actually, there's more. Okay, other than a priori, we use 1-pi, min-pi, and DNA sequencing algorithm, and you can also use many other independence analysis. Okay, many other dependent analysis. Okay, okay. Usually I use chi-square. Okay, chi-square also can be used to find the independent analysis. Okay, chi-square test of independence. Okay. Chi-square test of independence. Okay, to test whether it is independent or not. Okay. Okay, so that is about the association rule for the data mining algorithm. Okay, the keywords is we want to find the relationship and what is the strength, and we use our priori algorithm, okay, to find whether it is you have any relationship or not. Okay, next data mining algorithm is classification. Okay, like is classification. Okay, classification technique is a data mining technique that includes a process of creating and understanding recognition on grouping data and of data objects and ideas into categories. Okay. Okay, the classification algorithm include calculations that are predictively used to conduct assignments of the data to preset the data categories in order by having analysis of the training data set. Okay, let's say, let's say this is like example of, okay, like COVID test, like COVID research, something like that. Okay, so we know that we have a lot of attribute factor: age, sex, okay, health status, okay, symptoms, location, what else? Maybe okay, yeah. Okay, let's see. Okay, so classification is okay a tech process where you classify it into okay, and grouping the data okay into categories. Okay, let's say when I do the data mining, okay, I see that okay, these three in the same category, and these symptoms and health status in the same category. So this one would be category 1, this one would be in category 2. So that's a hidden underlying category, okay, that is lies in our analysis. Okay, so we can consider that age, sex, location is like demographic and like based on the category, okay, that is contribute to the COVID case, and system and health status is related to symptoms and health status is like related to the well-being and the fitness of the patient of the COVID cases. Okay, so that is good. We assume that all of the attributes are independent. Okay, then after that, we run the algorithm to see that there's a hidden underlying categories. Okay, based on this. Okay, training data. Okay, to set the behavior analysis of the training data set. What is training data? Training data is inputted in the classification algorithm to conduct prediction of the likelihood of the subsequent data to be in one of the categories that are predetermined. Okay, so first we use the training data. Okay, we already predetermine how many categories that we want. Okay, so like an example, the use of classification algorithm is the filtration of email to spam and non-spam. Okay, so we already put how many categories that we want, spam or non-spam email. Okay, some of it, okay, this one is we have a categories that are predetermined. The clarification technique that can be defined as a form of pattern recognition that uses the classification algorithm to have the application of the training data to find the data pattern that are similar in the actual data sets in the future. Okay, so we took some, okay, in the actual, in the training data, we see the pattern, which one is the spam, which one is the non-spam. Okay, so that when we use the training data here, we see that, oh, this is kind of like spam, this is kind of like non-spam. Okay, so your machine, okay, your software, your machine will understand, okay, to classify which one is spam and which one is non-spam. Okay, because we already predetermined the data, the training data. Okay, function like sentiment analysis are performed by the classification technique to categorize the text that is unstructured by the polarity of the opinion, whether it's positive, negative, or neutral. Okay, so we use sentiment analysis. Okay, sentiment analysis. Okay, performed by the classification technique to classify. Okay, the unstructured of the okay, unstructured text that are structured by the policy. So we see that spam, usually the email will be like this. Okay, non-spam, the email will be look like this. Okay, so we have a 5 major classification algorithm. Okay, naive-based algorithm. Okay, logistic regression, decision tree, K nearest neighbor, and also random forest. Okay, so we have few like 5 major classification algorithm. Okay, naive-based algorithm is based on the Bayesian Bayesian method. Okay, so it's based on Bayesian. Okay, so it's a classification algorithm that makes the calculation to find the possibility of where a data value or data point belongs within a particular category. Okay, so usually we use naive-Bayes classifier in the text analysis. Okay, in the text analysis. So this one is based on Bayesian algorithm. Okay, so if there are three statements, okay, what is the Bayesian? Okay, Bayesian usually is based on the conditional probability. So it's based on the three attributes. Okay, so if there are three statements, okay, a wonderful match, the election is one, and a forgettable match. They are supposed to be classified between spots and non-spots. Okay, so we know that one wonderful match is spots. This one is forgettable match, also spot, because it's a match. Election is one. This is a non-spot. Okay, so we use naive-Bayes classifier could be used to determine the category. So, okay, naive-Bayes, okay, we make the naive-Bayes algorithm, put in the training data, then we understand which one to put as spots and non-spot. Oh, stay here. Okay, so the naive-Bayes classifier uses the following formula in the text analysis, okay, to process in order to identify whether statements are belong to the spots and non-spot. Okay, so this is the Bayesian rule. Okay, this translates to the probability of data A if data B is true is equal to the probability of data B if the inverse of is true multiplied by the probability of data A being true divided by probability of B being true. Okay, this one is actually this one is posterior probability. Okay, this one is a likelihood time prior. Okay, over this one is the normalized constant. Okay, my PhD is about Bayesian. I don't want to emphasize more about this. It will be very complex and complicated. Okay, so but I just want you to understand, okay, to do the text analysis. Okay, to identify which. Okay, so this is naive-Bayes. Okay, second methods in classification is logistic algorithm. Okay, usually logistic algorithm we use only for the one that has two outcome. Okay, this all has a binary outcome is a binary. Okay, when the outcome is a binary. Okay, the outcome has two choices. Okay, good or bad, pass or fail, positive or negative. So which means that, okay, given that X is analyzed by the logistic regression algorithm to come up with a determination of one of the binary outcome present. The result must fall into one but the dependent data can only be categorical. Okay, in logistic regression, okay, the independent, which is the X, okay, the independent variables can be numeric or categorical. Okay, and the dependent, which is the Y, okay, can only be categorical. Why? Why it only has to be categorical? Because it's logistic. Okay, because it's a logistic, so okay, because this is a logistic, which means that okay, it can only have two outcome binary, which is yes or no, pass or fail, bad or good. Okay, so which means that the dependent, which is the Y, can only be categorical, which is two categorical. okay, which is two categorical. Okay, the formula used to come up with the logistic result is this. Okay, so you see here, Y is categorical because it has two categories. Okay, data Y is the dependent variable that can calculate the probability variable of when provided with the dependent variable F. Okay, this algorithm is used in image mining where it can be used to identify the object. Okay, used in image mining where it can be used to identify the object that are in a photograph when the probability of the object have a probability between 0 and 1. Okay, so it used also in image mining. Okay, so let's say that they look at in the object whether, okay, in the photograph, there's object yes or no. Yes or no, or even the text, if that's the text, okay, is pass or fail, something like that, okay? Okay. Another classification is decision tree. Okay, I have like explained to you a bit of decision tree. Okay, a decision tree is one of the common algorithm in data mining classification process. Okay, it is a classification algorithm to make orders of a class using precision. Okay, it is a supervised learning algorithm best to solve classification problem. Okay, the workability of a flow chart, okay, is similar of a flow chart. The data points are separated into two or more categories. Okay, like a real tree, the separation is conducted from a tree trunk to branches and finally to leaf. Okay, so you see here, okay, for the decision tree, okay, it's like most common, okay, because it's easier to do the classification using this method. Okay, like spots, okay, is, okay, so how to find this category of sport, racket sport, bad sport. Racket sport will be, sorry, racquetball, ping pong, tennis, badminton, and all that. Bad sport will be cricket and baseball. Okay. Next classification method is K nearest neighbor. The K nearest neighbor is a classification algorithm that makes use of the training set of data. They use a training set data in the future actual use. Okay, they use a training set of data. Okay, and they specify what is your K. Okay, the K nearest neighbor is a form of pattern recognition algorithm. Okay, during the classification, data is placed in the category of its nearest neighbor using the calculation made using the K nearest neighbor algorithm, and the dataset K is classified by conducting a summation of its neighbors. Okay, let's say K equal to 2 is placed in the class that is nearer to 2. Okay, so we use the training data. Okay, we use the training data and we find, okay, what is the, okay, let's say we put 2, where is the nearest neighbor when K is equal to 2? Then we select that, okay, as our first category. Therefore, they classify it. Okay, so K nearest neighbor is similar like clustering actually. Okay, it's similar like clustering. So we find that, okay, so it's number 2. So the nearest neighbor for K equal to 2 is here. Another one is another category, something like that. It's similar like clustering. Okay, so I show you. Okay, so this is like K nearest neighbor. So we call this as a K and N or K and N. Okay, so this is more non-parametric, it's like categorical. Okay, so we use a proximity to make classification or prediction. Okay, so let's say here, okay, so this one, you put the K is equal to this, maybe this one, maybe 2, maybe 1, okay? So then we can classify this is the nearest neighbor. Okay, this is category class B, this one is category class A. Okay, then we find what is the nearest neighbor. Okay, so we find that this is this, and we only select the one that is close to the our this one, nearest neighbor, this number of K. Okay, so that's a formula for the K nearest neighbor. Okay, we use Euclidean distance. Okay, we use Euclidean distance for the k nearest neighbor, which is this. Okay, another one, we can use a Manhattan distance. Okay, so which means that any distance, okay, that is close to our set up number of k here, the nearest neighbor, okay, will be selected. Okay, and we also use Minkowski distance, Hamming distance. Okay, there's a lot of other okay, I said. So how to define k? Okay, okay, how to define k? This is how you're going to define k. Okay, okay. Another one classification is random forest. Okay, random forest algorithm is a classification algorithm that serves an expansion of decision trees. Okay, it's like decision trees, but it's like wider than decision tree. Okay, real-world decision tree are first created with the training data. Okay, we use the training data as a decision tree. Then the actual data is now fitted in one of the decision tree as the random process. Okay, random forests tend to be beneficial as help solve the decision trees problem of having to force data point within a category. Okay, so random forest is similar like, okay, random forest is similar like decision tree. Okay, it's similar like decision tree. Okay, it's similar like decision tree, but multiple decision trees are created, okay, in a random forest classification. Okay, multiple decision trees are created using different random subset of the data. Okay, then we combine it. Okay, then we combine it. Okay, let me share this. Random. Okay, so this is like a random forest. Okay, so this one is a decision tree of S3 of a cat, decision tree of a dog. Okay, and this is a decision tree of a cat. Okay, then, okay, we combine it in the random forest because it's like this. Okay, between a cat and also decision tree for cat and for dog. Okay, so to be honest, I haven't used a random forest in my life. Okay, so this is something new. Okay, this is something new. Usually for classification. So this one is very new to me. Yeah, it's very new to me. Okay, I switch my screen again. Okay, any question of classification? Any question for the classification? There's no question. I proceed with the prediction. The mining algorithm that is used to find, okay, usually we use regression and time series to predict what happens. Okay, if regression, we mean that what happened in the past, and for the forecasting, what happened in the future. So we use the prediction. Okay, so it's a data mining technique that is used to in the identification of data points by describing another value that is related to the data point. Okay, prediction technique is mainly combined and used together with the classification technique. Okay, we use with the classification technique after we know that this one is based on this category, this one is this category, we proceed with the prediction. Okay, it used in a data analysis task for numeric prediction. Okay, in this model, we come up with a predictor that we make the prediction, okay, of continuous value function or ordered values. Okay, regression is one of the common techniques used by numeric prediction method. Okay, so usually we use regression. Okay, so there are 4 major algorithms that are used in the prediction technique. We have gradient boosted model, generalized linear model, which is the regression. Okay, K-means and also prophet algorithm. Prophet algorithm is actually similar like decision tree. Okay. So the gradient boosted model is a prediction algorithm that is used for the classification purpose. Okay, it's a similar like random forest. Okay, it uses decision tree, but the data used is generalized. Okay, it use the decision tree, but the data is generalized. Okay. The gradient boosted model used boosted machine learning technique, and the gradient boosted model algorithm built the decision tree on top of the decision tree. Okay, compare the random forest algorithm where the decision trees are not related to each other. Okay, the gradient boosted model help correct the error that made by the former tree. Okay, so which means that for the random forest, they just combine it, right? The category or the category, they combine it. Okay, for gradient, okay, error that made by the former tree. Okay, the resulting data from the gradient boosted model is considered to be more expressive, and there's a thoroughness in the classification of the data. Okay, but the downside is that it's slow and takes longer. Okay, it's slow and it takes longer. So gradient boosted model do the classification better than the random forest actually. Okay, so when you do the gradient boosted model, okay, it's actually like similar like classification decision tree. Okay, so it's like you create multiple weak models, then combine them together to get a better performance. Okay, to get a better performance. Okay, so there's many ways for you to find a gradient boosted model. Okay, but yeah, like I said, it's very hard because I don't show you how the outcome of the gradient boosted model and how it is involved in the gradient boosted model. Okay, but you just have to know that it's similar like decision tree, but it do better classification than decision tree. It's a random forest. Okay, generalized linear model is like actually it's same like it's a regression, but it's more than the regression. Okay, generalized linear model is a prediction algorithm that compares the effect of multiple variables on continuous variable before coming up with a list of distributors that will provide best fit model. Okay, generalized model, like I said, it is like regression model. Better not better one. Okay. Okay, by using the regression. Okay, for generalized linear model, you can combine the continuous and also with the categorical. Okay, usually we use the continuous for the generalized linear model. The major advantage of this algorithm is that the data is very quick to train. Okay, the generalized linear model work with categorical predictors while making straightforward interpretation. Okay, usually we use generalized because it is very easy to do the conclusion. Okay, and if you have any value, you can just put it here. Let's say put number 2, say here we put number 3. We can find the prediction by substituting the value in the equation. Okay, generalized linear model algorithm also ensures that the understanding of the predictor's influence on the outcome is quite clear, and the algorithm is a large set of data to produce better results as it produces many outliers. Okay, so after we do the attribute aggregation, after we do the attribute removal and all that, okay, we must ensure for you to do the generalized linear model, your data must be big. Okay, so that you will know, you will get a better prediction model. Okay, then to find a harmonious model to run in generalized linear model is not easy. Okay, you have to run, then see that oh, the model is not significant, then you have to remove it, then add more, then you have to remove it until you find the best fitted model. Okay, another prediction method is K-means. Okay, K-means algorithm is a prediction algorithm that is involved with the placement of the data points that are unlabeled groups. They are separated based on their similarities. Okay, this algorithm is also used to conduct clustering. It is better if the set of data to be clustered is large and there is need of personalization. Okay, by using K-mean for the prediction, okay. Okay, this one is more in clustering. Okay, I never use in prediction, but I use in clustering. Okay, in cluster. So again, we need a large set of data. Okay, to run for the prediction by using K-means. Okay, so if the data, okay, so we need to do the placement of the data that are unlabeled in group. Okay, and based on the similarities, okay, you can find the then you can find the prediction of it. Okay, whether this one is in a cluster, this cluster, or that cluster. Okay, so we can know that unlabeled in groups. Okay, so when we use K-means, we can find whether this data is belong to this cluster or the other cluster. And profit algorithm is a new model. Okay, it's similar like generalized model, but it's more detailed. Okay, it's a prediction model that is commonly used in forecasting and time series. Okay, so it used in a forecasting and time series, which means that, okay, we can predict a test that is beyond, okay, our time series. Okay, so which means that if you want to forecast like 3 months after this, like 4 months after this, okay, so it more used in profit algorithm, because in profit algorithm, the model is more detailed. Okay, it's more detailed. Okay, this algorithm works well when conducting capacity planning. Okay, it's a very labor intensive algorithm that requires highly skilled people to operate and bring across Facebook profit algorithm. Okay, they have a Facebook profit algorithm. They name it Facebook because it was found by one of the Facebook programmer. Okay, Facebook programmer, how to identify the trend, how to forecast the trend, okay, how to find the pattern, and also the association, the classification by using the profit algorithm. Yeah. Okay, so okay, for K-means, it's more about clustering. So you don't have any, let's say okay, for gradient boosted model means, okay, it's similar like random forest, okay, like decision tree, which means that if you don't know, okay, which one is belong to, whether it has association or not, okay, you can use the gradient boosted model. For generalized linear model, it's more towards the regression. Okay, so you can predict at any point in the data. Okay, you can provide any point of the data, then predict what is that. Okay, but for K-means, it's similar like cluster. If you don't have any, like you have any data, you don't know for which category it belongs to. By using K-means, you will know which data belong to which category. Okay, but for profit algorithm, if you don't have any idea what will happen in the future, okay, what will happen in the future, so you use the profit algorithm, okay, to predict what will happen in the future. Okay, so these four methods have different function. Okay, one is for the association, one is for the prediction, for the current, one is for the clustering. Okay, same like you want to find which category it belongs to, and profit algorithm is what you're going to predict what happens in the future. Okay, so any question? Okay, for clustering and also discriminant analysis and trend analysis, I will discuss in next class on Monday, on 5th of February. Okay, I will begin with 1 hour class, or maybe less than that. Okay, now maybe less than that. Okay, then we and after that we continue with midterm, your midterm. Okay, I hope that by this next week, yeah, by next week I can sort my Europe. Okay, I can sort my URATs and able to access it. Okay, so like I said, for midterm, it will have two sections, section A, section B. Changing rules are with, or if I repeat again, if there's any changing rules, I will inform you via announcement in Europe. So please put notification in your Europe rules. Okay, I will inform in the announcement in Europe. Okay, so how chapter 1 to 4. Okay, you read all of the learning outcomes. So I will ask you based on that. They have two sections. Okay, section A and B. Section A like short question. Section B will be easy. Okay, so for your final assessment, I will tell you, I will like, because I'm still drafting it, okay, I will inform you in next class on Monday. Okay. Any question before I dismiss the class?
No, Dr. Lana.
Okay. Okay, thank you very much for your time today. Okay. I'm heading to a like wedding after this. Okay, thank you very much for attending. Have a great Saturday. I know that you'll be busy with the like class and also
You
with family.
you bought your
Okay,
bicycle
thank you very
already?
much for coming. See you next Monday. What?
You bought your bicycle already?
Oh, not yet. Not yet. Yeah, not yet. Yeah, because some said that I should buy a second-hand bicycle, and some said that I should buy a new one. So I'm still deciding, but I already know what I'm going to buy. I like Giant Llama and Giant Envelope. Okay, because the geometry, okay, is suitable for the woman, and it's a bicycle made by woman for woman, something like that. Okay, I haven't tried because the Giant will be at I live at Ampang, okay, so it's a bit far for me to travel. I don't like the traffic jam, to be honest, to PJ. Okay, the Giant outlet, the nearest to me is in PJ. But last week, so I'm just survey for my husband. My husband also already know what bike that he wants to buy. Okay, but yeah, we like still deciding. Okay, and my husband also like the now I don't know now the corporate. Okay, us because he is in a corporate. Okay, so they want to sponsor a bike for him. Okay, now golf is not like the corporate sports anymore. It's now is cycling. Now I know cycling is a new corporate sport, not golf anymore. Maybe golf is for like the one that is like more chill, but I don't know. Now corporate people nowadays likes so that's why we hold on, because they want to okay, they want to give my husband bike for him, okay, for the corporate thing, okay, because they have like I don't know the corporate a corporate trip, okay, by cycling or what. Okay, now I know. Okay, I don't know that the people nowadays prefer cycling over golf.